Be isolated from the air ground, which will be continually fed in real time to the news center.
Problem right at the moment is one of attitude and guidance in the spacecraft. With the power down, I gather Wally Schirra, who was with me, they are not able to determine their exact attitude through their instruments, and therefore they have said they are navigating by simply viewing out of the window the terminator, the sun line on the moon.
That's one of the things I did read, Walter. Now, you must realize we're all trained to look at the star pattern, the celestial sphere, as we call it, to determine which star is a navigation star. We have 37 stars that are part of our computer program. They can be picked up out of the window, and that's part of what you heard in this last transmission. So a crude attitude can be obtained initially with the stars. Then we have a device in the vehicle, be it the LEM or the command module. In this case, of course, they're using the LEM, to look at a known star. And that data can be transferred from a little optical sight. It's kind of fun. I developed that back in Mercury days. To determine their attitude celestially, which is the inertial attitude we talk about. Now, if the LEM computer works properly, they can attach the same star by moving the LEM, the whole combination, the LEM service module, command module, with the LEM propulsion system attitude control to get a fix.
Now, the reason that they need that attitude so precisely is to fire the engines.
Yes.
They have to be fired with them in the right attitude, or, of course, the thrust is in the wrong direction. Sure. They go off in the wrong direction.
Now, this is all within the capability of the computer program. It's really, and I guess as simply said, you can talk to the LEM computer through any variable, much as this optical alignment site. We call it the COAS, which is just a collimating device.
But now there again, using that computer is draining some of that precious power that they're
from the
taking
LEM.
off the batteries.
That's correct. Now, what there's one of the things I read.
Excuse me, Wally. Roy Neal has been in mission control. Let's listen in.
Good.
Control in Houston are gathered around the consoles. They are talking at the moment through the capsule communicator Jack Lossma with astronauts James Lovell and Fred Hayes in Aquarius, the lunar module, which is in control of the situation, moving toward the moon. Jack Swaggart is in the command module. That module, Odyssey, currently powered down, having suffered trouble in 2 out of the 3 fuel cells, trouble sufficient to abort the mission of Apollo 13 to the moon and force a return to Earth. A return, however, that will not begin until the lunar module engines are fired up to accelerate the spacecraft, speed it up so that it will go around the moon and then return to Earth. That burn is expected in about 20 hours and a half, about 20 and a half hours from now. And this means that the astronauts will be returning to Earth a good deal earlier than expected at 142 hours into the mission, 142 hours after they took off. Right now, aboard the spacecraft, the men are setting power levels. Here at Mission Control, the various support sections are figuring out at what power levels they can operate. The computers are being checked and aligned. The astronauts are looking out the window, checking stars. And that's the situation right now. To repeat, Apollo 13 will not land on the moon. Instead, engines will be burned aboard the lunar module some 20 and a half hours from now to send it on its way back to Earth. Roy Neal in Mission Control.
Back here at our CBS News Space Center in New York, Wally Schirra and I might show you what has transpired here this evening. This is the configuration that the spacecraft have been in since Saturday afternoon when they docked after the very successful takeoff from Merritt Island, the Kennedy Space Center in Florida, with the command module here and the lunar modules here. What has happened tonight is that the service module has the 3 fuel cells in it that supply fuel, basically, to the command module for the flight out and back. It is the service module that is jettisoned just before the command module makes its re-entry when it comes back to Earth. And all of the power supply and life support and environmental equipment, basically, for long trips out to space are here. The Now, this engine is the Service Propulsion System engine, 20,500 pounds of thrust. It is that engine which is depended upon to boost all of this configuration, first into the lunar orbit and then out of lunar orbit back home. Without that engine, presumably, they couldn't come back, except, of course, that they do have the lunar modules here below. Now, normally, these would be detached, of course, make the lunar landing, and once they have made the lunar landing, the top section of this, the ascent stage, comes back and rejoins, then this is jettisoned, and the Service Propulsion System is left to bring them home. However, with them still attached, as they are now, they can use the Descent Propulsion System engine, which is here. The reason they can use this, whereas they cannot use the Service Propulsion System engine, is that this operates on batteries. It has its own battery supply, not fuel cells. In other words, it doesn't generate electricity. It simply uses it in a storage battery, just like in your automobile, as opposed to the fuel cells, which generate electricity. So with those batteries, they've got just a limited amount of electrical power. But that is enough power, and this engine, which runs from 1,050 to 9,500 pounds of thrust, is throttleable, as so-called, is capable of taking the whole shebang here out of lunar orbit and send it on the way back home. Now, they don't have any backup system anymore. That is the backup system. That's the one that they would have used if the Service Propulsion System engine had gone out while they were still in lunar orbit and before they were detached from this. Now they can use it to come home, and that's what they're going to have to do. The maneuvers will be then, first of all, to get lined up, as we were talking about a moment ago, without perhaps some of the computer help that they would have normally have, but with the star sights that Wally was just telling us about. They will get lined up as accurately as they can, and it must be quite accurate. Then they will fire this engine down here at the bottom to speed them up. By speeding them up, the moon doesn't catch them in quite the same orbit it would have normally, and it, in effect, reestablishes what is called a free return trajectory. In other words, it speeds them up enough so that the moon just catches them with its gravity and throws them around in a slingshot maneuver, but just precisely, if this firing is correct, so that they will return to Earth. Then perhaps they will need another firing of this engine on the way back to Earth to line up exactly for their landing on the scheduled spot in the Pacific. But at any rate, that's what is being planned right now. There is no further thought of possibly going to the moon, unless by some miracle, I suppose, those fuel cells came back on the line, but that's not even in the books, is it?
No, I wouldn't anticipate that. Once the fuel cells are gone, they're almost irretrievable. The one consoling thing, at least the last I've heard, is that a third fuel cell, which is number 2 in essence, is available on the line, but they've conserved it. You can use the fuel cell to recharge the batteries in the command module, which is significant in that itself can fly a re-entry without the service module, and does normally.
Yeah. The only thing that can re-enter, the only thing that has the capability of re-entering is just the command module.
Just the command module.
So they have to be able to jettison the service module, and of course they'll be jettisoning this portion, the landing modules, as they have established that they're on the way safely home and have enough consumables. Now, Wally, are consumables any problem? Oxygen and water. They get some of their water supply as a byproduct of the fuel cells, I know.
Right.
But they also have pretty good supply on board, tanks that are already filled, aren't they?
By now, the water byproducts of the fuel cell should have filled up what we call the potable water tanks, so that supply is readily available. And it's a pneumatic source, so it just basically squeezes out from an air pressure system. It's actually oxygen through a water gun, so they can drink that. Now, in the LEM, there is water also stored there for the crew.
What about...
I'm not worried about water. I'm not worried about food.
What about
the oxygen itself should flow through from the LEM or from the command module, because it's gaseous and should come through. Now, there may be some electrical circuits that must be activated and can be even by the command module to bring this through. But to circulate the oxygen, we have some pumps. We call them compressors, but they're much like little fans that merely circulate the gas through the vehicle, so that you don't have layers of impure gas and then layers of good oxygen. Well, this shouldn't be too much of a problem. The load that's required for that is very low.
So
The electrical load, of course, is what I'm referring to.
So really the problem that faces the men in mission control in Houston and Jim Lovell and Jack Swigert, Fred Hayes aboard Apollo 13 is simply the one of getting the LEM descent stage firing off at the proper moment, proper time, with the proper thrust. Presumably that's available from the battery supply they have. The concern at the moment then is limited to that. And of course, the feeling that we've aren't going to make a moon landing this time.
I would say we can just forget the moon landing for now and concentrate on using the LEM descent stage, as you aptly described it, as the propulsion system. Now, the attitude that they will acquire can be acquired either by the reaction jets. Notice these small little thrusters you see here. These are very similar to the ones you see on the service module. So they can use those to establish the attitude of the whole stack, as we might call it, or the shebang, to get it oriented in the proper.
They're having a little problem right now. We've just been advised from Mission Control in Houston. They're rolling around their fore and aft axis, up and down axis, and Lovell says this slight roll he's trying now to stop. What would that indicate?
He's probably got to learn how to use these with what I would call the combined stack. Our training normally involves flying the LEM with the two stages as one system, not controlling this whole stack from the LEM attitude control system. If you see what I'm trying to say, in contrast to use these to control it. So these are off-center from the center of mass.
But now, Wally, learning to use a new system like this in the past has meant an expenditure of quite a lot of fuel.
Well, I heard that one report from Mission Control. They've got 20 hours, so I think he'll sneak up on this one. Yeah. He's not going to rush into it. Now,
20 hours before the firing.
This is why we still have test pilots flying these things, and I'm quite pleased to realize we have 3 of them up there.
It's interesting that Jack Swigert, when he was suddenly called off the bench of the backup crew to replace Ken Mattingly for this flight, you made the comment down in Florida Saturday that, and several of the other astronauts and others we heard from said that in one way he was the best man possible as a substitute, since he wrote the book about the command module and its possible malfunction. So if anybody knows what might be wrong in there, he does, I suppose.
I'd say Jack is the best man to have aboard right now, and I'm sure that none of us would envy that slot. But in any case, I would say that if there's a solution to this problem, he's going to help unearth it.
Now, the timeline of events, as I understand it, and we're waiting for that news conference in Houston, I suppose it's about to start any minute now. We'll cut in when it does. The timeline is that they will fire this descent stage engine 20 hours from now, roughly, which would put it at about, 9 o'clock tomorrow night. I think that is the time that I had heard earlier, 9:23 or something like that, Eastern time tomorrow night. At that time, they will be on the far side of the moon, just making the first kind of turn around the moon as the moon has caught them and is swinging them within its own gravity. They will come on around the moon and fire this engine at that time to boost them out of moon orbit at precisely the right moment to put them back on a trajectory toward the Earth. So the critical time for them now, as far as the maneuver goes, is at 9-something tomorrow night, Eastern time. If all goes well then, Odyssey, the command module, will be splashing down in the Pacific, according to the present calculations, at 12:13 p.m. Eastern time, Friday. It was intended, of course, that it land on the moon, the lunar module, on Wednesday night. The walk on the moon was scheduled for Thursday, and the entire spacecraft, after another day of orbiting the moon, was scheduled to return on the following Tuesday. But now all of that schedule has been changed, and we have something of a crisis in space. I gather, Wally, that you are reasonably confident that all of this can go now as Houston has figured it out and the fellows up there in Odyssey.
Walter, one of the things that comes to my mind, because people always ask us about it, is do you have fear? And that's a great luxury. You can't have fear in this environment. If you do, the next thing you approach is the luxury of panic. And these men are trained to fly in the most extreme circumstances. And in the past, almost all of our missions have been, in contrast, a piece of cake, because we've always trained for the worst case. Now, this is one of those bad cases. I wouldn't say it's the worst case. So
Wally,
that's it.
Excuse me, but we're going to Houston now. The news conference is just beginning. Christopher Kraft Center is speaking.
Should start out by saying that we have a serious problem in the command and service module. We appear to have had some kind of accident with the in the region of the fuel cells and the oxygen tanks. We have not tried too much to reconstruct the what has happened, because we were more concerned at the moment for getting the situation under control. As you have seen, we've begun to use the LEM as a device for keeping oxygen in both the command and service command module and the lunar module, and we're using the power system from the lunar module. It appears at the present time that everything is under control and that we have a safe situation at the moment. I think Colonel McDivitt may want to give you some more details on the systems, and Mr. Schoberg could certainly talk about the operations plans that are going on at the present time in the control center.
Right, Chris. The way we have the spacecraft configured right now is with the CSM powered down completely. Before we powered it down, we were able to isolate the surge tank and the emergency repress tanks in the command module. These provide oxygen for reentry, so we have a command module that has oxygen for reentry. It has the reentry batteries, it has pyro batteries, and all the systems that are in the command module. Our malfunction apparently occurred in the bay, which includes the hydrogen tanks, the oxygen tanks, and the fuel cells, and was in no way connected with anything with the command module. We should be able to provide power, electrical power, from the LEM for the return voyage to Earth. We should be able to return on the oxygen within the LEM, and we will be using the lithium hydroxide out of both the command module and the lunar module. We can still power the command module from the lunar module at low power levels through the wiring which is normally used to power the LEM from the command module. So we expect that we'll be using a dual spacecraft mode from now until the time that we get back to Earth. We'll be firing the LEM engine at some time later to accelerate our return voyage, and I think Sig will probably comment on that best.
Yeah, the minimum return to Earth time, this would be a total flight duration, would be about 133 hours. That would result in a landing in the Atlantic. That's one option we have. A second option would be to go to the Mid-Pacific line. That would take about 142 hours total flight duration. The burns to get you back would be made at about between 77 hours and 79 hours of flight from liftoff. We'd anticipate that the descent propulsion system would be used for either of these maneuvers, and it has the capability of either of the ones I described.
We're ready for questions now. Please wait for the mic. We're going to have to get all this in. Where are we? Are you ready? Let's start here and work across. Mark Bloom, then we'll go this way and we'll turn to the aisle.
For Jim McDivitt or anyone who wants to ask, how much electrical lifetime do we have in the LEM, and how much oxygen lifetime? How long do we have?
Well, Mark, it depends upon how we use it, obviously. We have 4 batteries in the descent stage of the LEM with 400 amp hours each. We have 2 batteries in the ascent stage with 296 amp hours each. If you rough that out quickly, it says we can use power at about 25 amps. steady state current until we get back. Now, we'll have to arrange the electrical profile so that we can bring up the systems to perform the dock DPS maneuver, and then we'll power down to minimum levels and go along like that. When I left, we had an ample power supply to do the whole mission, but we were still roughing it out and trying to get in a configuration which we knew. Oxygen, we have 48 pounds of oxygen in the LEM descent tanks, which is more than adequate to do the mission. We also have a couple pounds in the LEM ascent tanks. I think I said descent. Descent tank has 48 pounds. The ascent tanks have about a pound or so each.
Point out that we have locked up the CSM systems to preserve that spacecraft for reentry, both in terms of power and oxygen. So it is sufficient to support entry.
The command module is completely intact. There's no problem with it at all.
I wonder if we can expand a little more on the possibility of an Atlantic Ocean landing and what the recovery posture is for the Atlantic.
For an Atlantic landing, we would have airplanes with parajumpers on the scene at the time of landing. We're presently surveying that area of the Atlantic. It's, as I remember, it's about 20 or 25 degrees south and about, I think it's about 25 or 30 degrees west longitude. And we're presently surveying the area for ships of opportunity. But we do not have a planned recovery ship in that area, as you know.
So let me follow up on that. Would you say that now it seems a great deal more likely that you'd go for 142 hours and the Pacific, where you have a recovery capability?
I think that's a good possibility, but I'd like to reserve judgment until I see what happens in the next hours. We have some 18 or 19 hours until that burn has to be made, so I think we'd certainly be watching the situation. The Pacific is a lot better from the standpoint that we have the ship there. It's better from a network standpoint, so it's a preferred place, even though it might take a little longer.
Chris or Jim, can you tell us where the 3 astronauts are and how they will be living in their return to Earth?
Well, when I left, I think that Jack Swigert was still in the command module and Jim and Fred were in the LEM, and I think that they'll be living between the 2 spacecraft until they return. Sometime before reentry, of course, the 3 of them will return to the command module and put the hatch back in and jettison the LEM, jettison the service module.
If I were going to guess, I'd guess that the 2 of them would sleep in the CSM while the other one stayed awake in the LEM. I would guess that they'll probably go to some kind of shift like that.
Yeah.
Can I follow it up? How are they going to be getting oxygen and heat in the command module? From the LEM?
We're going to be running one environmental control system or the other. Initially, we'll be running the LEM system. That's what we're running right now. Now, intermittently, we'll run the CSM system to make sure that we keep the atmosphere in the LEM free of carbon dioxide. So we'll be alternating. That's why I say there'll be people in both spacecraft.
All right, let's take them over here, then we'll come back on this far side. Right there, yeah.
Yeah, will somebody explain to me what you mean by a ship of opportunity in the Atlantic? Is that some merchant ship or Russian sub that happens to be
It could be a merchant ship. It could be, I suppose it could be a foreign nation's naval vessel. Any of that kind of thing.
You mean any ship in the air?
Yes, sir.
Right here.
Chris, has this abort situation or altered trajectory ever been run on simulators in just this way?
Oh, yes. Many times we run all kinds of abort situations, and if you recall, in Colonel McDivitt's flight, we actually burned the DIPS engine attached to the command and service module. The autopilot in the lunar module is designed to carry out the maneuver under those circumstances. That is, the digital autopilot to damp the oscillations of the combined spacecraft. We are looking even at the possibilities of dropping the service module, but that particular type of maneuver has not been tested in flight, and we'd have to make ourselves certain that we could control the spacecraft under that kind of CG and inertia conditions. So that's kind of unlikely that we would do that. If we did that, it would give us that much more delta V, you see, because we'd get rid of quite a bit of weight from the CSM.
Zach Strickland?
Chris or Jim,
If you've got a situation where the LEM oxygen system can provide like 50+ hours for 2 guys, how do you equate that with 146 hours return if you don't have any kind of environmental control operation in the command module right now?
Normally, on the lunar surface, we plan on 3 lunar surface repressurizations. It actually has enough for 4. Now, there's about 6.6 pounds of oxygen per repressurization required, and the LEM leak rate is about 0.08 pounds per hour. The metabolic rate is a little bit, and we're using probably 0.2 of a pound per hour, so we've got quite a large margin there.
You recharge the plisses also.
Pardon?
Let's get this straight if we can. You're saying you use 0.2 of a pound per man per hour?
About a number is 6 to 8 pounds for the 3 men per day.
6 to 8 pounds per all.
Correct, and that plus what you might have for
yeah, you have
leakage.
to take in the cabin leakage too.
All right. Let Jack finish.
If I can follow up here just a second. Have you got enough oxygen to get them back safely?
Yes.
All right, over here.
According to the press handouts, the Navy's got a standby task force in the Atlantic to recover if necessary. You wouldn't go to this, you'd go to the Ship of Opportunity, emergent ship if necessary?
We don't have a U.S. Navy recovery ship in the Atlantic.
Is deemed necessary for this mission?
It was not deemed necessary for this mission.
Sig, where was the Atlantic recovery point again, geographically, if you could, and the Pacific point?
This is rough, Paul, but it's something like 20 to 25 degrees south latitude, and I think it's about 30 degrees west longitude.
Just below the point of South America there, Paul.
The bulge in that area.
Due south of that.
You mentioned that you should be able to generate around 25 amps per hour, and you have to divide that out against the loads. Will there be sufficient power for the transponders so that you can get a good track on the spacecraft?
I will be able to bring them up when we need to, and I believe that we will have that kind of power. I really don't have that close a handle on the power. We came over here before we had all those details worked out to that level.
As long as, with the Omnis and the 220-foot dishes, I don't think we'll have any problem there.
Also, I appreciate that you haven't been able to give any thought to what caused all this, but I was looking through the transcript, and there were certain problems with the O2 tanks, and cryo temperatures, and problems with fan cycling and stratification. Because this, apparently one of the tanks was oscillating very rapidly in temperature, and this was noted earlier today. Does this give you any thought of what might have happened?
No, not yet. Stratification is something that typically happens in these tanks, and it's nothing that we haven't seen before. Right now, I have absolutely no clue to what happened. We had something...
It was pretty widespread, we know.
Rather violent happened in Bay 4, we think. Something happened to the fuel cells and the oxygen tank, and they were down in that area. It was a rather violent kind of thing because it apparently reset some of the check valves in the RCS quads, which are susceptible to shock. But as far as what exactly happened, I have no idea.
Chris, are you confident that you have enough power under the current configuration to bring the Apollo back in?
Yes, but I think we'll have to be very frugal in how we use it, and that's what you've probably heard some of the discussions back and forth between the crew. We were trying to consider whether we would keep the platform up, for instance, between now and the time you go behind the moon, in order to maintain that alignment so that they wouldn't have to do another alignment when they get ready to do the burn on the dips and so on. So it will have to be very carefully used between here and Splash.
And how do you feel in point of concern between now and Gemini 8?
Well, I guess I would have to say I feel a great deal more concerned. We're still something like 70 to 80 hours away from the Earth. And in Gemini 8, we were never more than an hour and a half to get to a recovery point and never more than 20 minutes to land.
Carl will take one back in and then move up this way again.
At the time that you left, what was the situation with regard to venting to the outside and motions of the spacecraft from that? Was there any?
I
don't know.
I can't
The venting
recall.
The venting had been decreasing, and if we were leaking probably from that bay, and it looked like the pressures were all dropping, so I would assume that the venting had gone down, but it was a little difficult to tell from the conversation. I would assume that its venting had decreased considerably.
You were not getting any particular rates anymore at the time you were leaving?
Not that I recall. I think they had the LEM RCS system up, and so it would be difficult to tell even then whether they did have any rates.
They were transitioning from one spacecraft control system to another and running back and forth through the tunnel and aligning the platform. There's an awful lot of activity going on, and we didn't ask them what the rates were.
I believe I heard Fred Hayes mention that it might be considered to use a deep space abort in order to immediately get the burn over with and power down the LEM so you wouldn't have that drain in keeping it powered up till they get around the moon. Has this been completely disregarded now?
We can't, the position we are now on the Earth-Moon plane, we have to go around the moon to get back if we're going to use the DIPS engine. You would have had enough capability with the SBS engine, but of course we don't dare use that now. So we have to go to the backside of the moon and come back.
I have a question in three parts. First of all, if they do choose the Pacific method of recovery, will the recovery point be changed from original planning, or will it still be the same?
I think it's moved west and south some. I think it's about 165 degrees west and some 20 degrees south. It is farther south and farther west than the end of mission land.
Would this, the other two questions kind of combine. If you did land it in the Atlantic and you did have to go to a ship of opportunity, would you hesitate at all to ask any ship of any nation?
No, sir, I wouldn't.
And will this necessitate future thinking toward a backup recovery fleet in the Atlantic?
We certainly will reassess that, yes, sir.
Have one in the back there.
Chris, will you come in at 400K, and will there be any problem in jettisoning the LEM at entry, or
All that's
what
done.
will be that mechanics?
It's done the same way as it is around the moon, and the same way coming back from the moon with the service module. You have pyrotechnic batteries and separate pyrotechnic lines, electrical sources, which are dependent only on those power sources. So we don't have any problems there in terms of separation. Now, the dynamics, mechanics of the thing would not be a problem either.
For Jim McDivitt, is a situation like occurred in Bay 4 something that might have occurred if it was hit by a meteoroid? And for Chris Kraft, in following up your earlier comments, do you feel they have a good chance to make it back?
Well, you asked me first. There was something which appeared to be quite violent that occurred in Bay 4, and yes, if you were struck by a meteor, it would be quite violent. I'm not assuming that's what happened, Mark, but that could have done it.
Yes, I think their chances are excellent at the moment, assuming that the lunar module continues to operate well.
Can you think of anything else that might cause such a violent event besides a meteor?
No, we could probably think of an infinite number of things that could...
Well, 2 or 3 that would be within the realms of likelihood, I mean.
I guess I really... There are a lot of things that could have happened. It would be just pure conjecture. Anything that's down there that's pressurized could have let go, and there are all kinds of pressurized things. There are pressurized hydrogen, nitrogen, oxygen, fuel cells. It's a very complicated bay that this happened in.
What is the moment that you have to get everybody out of the LEM and back into the command module and seal it off and get ready for entry? I mean, how late can you continue to use the LEM before you have to go to the batteries on the command module?
It's pretty late. It doesn't take too long to get back in the CSM. The thing that you want to make sure is that you have adequate time to put the hatch in and blow the LEM off, and that really doesn't take very long.
I'm sure that will be a process where a couple of them will get back in the CSM, get everything set up, and they'll do that as late as possible.
I guess we'd have to work that out. 30 minutes or hour or 15 minutes or some range like that.
want to start using the CSM batteries as late as possible.
Okay, we're going to come up the middle. Harry?
On the present trajectory, how far beyond the moon will they go before they start to hook back? And what would the miss distance at the Earth be without a correcting burn from the dips?
Well, on the present trajectory, we would come within about 60 nautical miles of the backside of the moon. We are not on a free return trajectory at present. It would take a very small burn, say in the next 5 or 10 hours, to get us back on a free return on the order of 20 to 40 feet per second. I can't answer your second question about how far we'd miss. I don't know.
Right here.
Will the dips burn be the major rocket maneuver you will make on coming back, and if so, where will it be, on the far side of the moon? Or
It'll be on the far, yes, it will be the dips. It will be on the some place between Paraloon on the far side of the moon and 2 hours after that.
Let's pick these up coming up the middle of the aisle. We'll just take them both sides here. All right, Paul, go ahead.
Do you recall the approximate mileage at which points you could still do a deep space abort and come back? What is the crossover? 140, 150,000?
It's probably farther than that, Paul. I don't remember the exact number, but I think at the time of this incident, if you'd used the SPS engine, you could just about have done it, but it would have taken just about the whole thing.
176,000.
Something like that, yeah.
Yeah, if I recall, Paul, I think the number was 9,000 foot per second and about 140 hours.
What would cause you to choose the Atlantic over the Pacific for recovery? And are you now surveying the Atlantic to find out what ships are available to you?
Yes, we are surveying the Atlantic to find out what ships are available. I think the only reason you go to the Atlantic, if sometime between now and the burn, something would happen to make you very time critical in getting back.
Burn more quickly or sooner?
No, it's a bigger burn to go to the Atlantic. It's about 2,000 or 1,900 feet per second and gets you back some 9 hours earlier.
how many feet per second?
It's about 900.
Let's come up there. We have the gentleman in the middle of the row there, in the khaki jacket.
In the transcript, and I'd like to read from this, Lovell says, yes, I've got to put the cabin refit valve in there. Every time he does that, our hearts jump in our mouths. Now, I don't understand what he's talking about here, but could this have anything to do with the accident? If something happened that made their hearts jump in their mouths, what was it?
I think he's talking about the cabin repress valve in the LEM, which goes bang when you operate it.
McDivitt said that any pressurization could do anything. Is there any link here?
Any pressure?
No.
I guess I don't understand the
It
question.
didn't. What you're asking is, did that statement have anything to do with the accident? And I think definitely not. So he was talking about something that went on in the lunar module as opposed to where the accident occurred in the command and service module.
I'd like to go back to Bay 4. Do you expect to be able to tell exactly what happened there, and if so, how soon?
We have people working at it right now, and I don't know whether we'll ever be able to tell exactly what happened there or not. We're reducing the data like we do on all of the space flights and whenever we have an anomaly, and to date we've been quite successful in determining what happened. Whether or not we are in this case, I have no idea. We're certainly going to do the best job that we can. Well, sometimes it takes a long time. I have no idea on this. I haven't seen the data myself at all. We were trying to figure out what to do rather than to play out the old data.
And that's what we'll be doing till we get them back on the water, is concentrating on everything that is their lives are dependent upon at the moment rather than worrying about the accident, because there's nothing we can do about that now. The service module is no longer useful in most cases because the oxygen is depleted. So other than the fact that you've got some propulsion left, and the batteries in the command module, and we're going to worry about those situations from now to splash.
Initially, we were trying to find out what was wrong down there so we could possibly correct it before we lost the oxygen. We weren't able to do that in time, and I think that we'll put that effort on a very low priority right now and work on the other stuff. Pardon? No hints.
What about your thermal control situation? Do you expect any problems from heat because of your configuration now?
Well, we're not going to be able to just maintain a single attitude hold all the way to the moon and back. We're going to have to do something, and we've been working on that. I guess the guys are working on that now, aren't they?
I don't think we can answer that question truthfully, because we've never had a situation where we've not had powered up conditions in the command module and powered conditions in the LEM, so that's probably going to be a real-time situation.
Chris, at the risk of asking you to oversimplify a very complex situation, and certainly I don't mean this facetiously, is there any concern, real concern, can you get them back, taking into consideration all the imponderables, the power, the oxygen, the landing area, and all this sort of thing? Is this...
If the situation remains stable as it is at the moment, there's no question but what we have the thing under control and we can return the crew safely to the Earth. Now, we're going to have to make some compromises in procedures as how you do that, but that can be done. We've got a number of different ways of doing things, like re-entry. If we couldn't, for instance, get the platform up, we have what we call the entry monitoring system. We can enter at constant G if we had to with no entry monitoring system. If everything remains as is, we can get them back successfully. Now, if there was some change in the status of the lunar module, then that might mean something else, and we will keep you appraised of that situation.
All right, right here, what can you anticipate that might happen that already hasn't happened? Can you give us an indication of what could happen?
Well, you might have some problem with some system in the lunar module that would put us in a very serious situation, like a leak in the oxygen system or something that would happen to the electrical power.
There's no indication now that there's anything wrong with the LEM. It's performing properly, and like Chris said, if everything works the way it is now, there's no doubt that they'll come back all right.
Okay.
What time did the accident occur?
I don't have an exact
Yes,
time. It must have been 56 hours.
Yeah, 55 and a half to 56 hours in that time period. I didn't
All right.
mark it.
Will the crew be wearing their space suits, or will they be shirt sleeve, or how will they be traveling the rest of the trip?
Well, they're shirt sleeves right now. I would guess they'd probably stay shirt sleeves. I see no reason to go back to the suits.
Yes.
Yes.
All right, we're going to take these two here, then we're going to come back on this side.
Jim, I'm not clear on what the venting did to the spacecraft's attitude and pitch roll and yaw.
Well, he had a negative pitch and a negative roll, and that's one of the clues that we had that something happened in Bay 4, in addition to the fact that we had all these other anomalies to the equipment that's in there. It meant that it was pitching nose down and it was rolling to the left.
I think the other thing you have to remember is that we have certain instrumentation that we can believe or not believe. I mean by that when you have something like this happen, you don't know that you're not reading false information from some of the instruments. So you have to look at those and see how they failed, etc., and see what the measurements are, and see which direction they went when they began to fail, to see whether you're reading true information.
All right, this one, and then we're going to come back on.
Chris, could you put this in a somewhat larger perspective? It seems obviously that if this happened on the way back, the situation would be critical. I mean, it would be fatal.
Indeed it would.
You discuss this thing from the standpoint of the resources you're left with when it fails at this point in the mission.
Well, and any time that you still have the lunar module in the condition that we have it in this case, where we've not used any of its consumables, then we're in a very good situation. We've always called the LEM a good lifeboat under those circumstances. If at any time in the mission, however, the LEM had separated and we had gotten ourselves into a rendezvous situation, or the command module being around the moon, then what you state is absolutely true. It would be a fatal situation.
What is the critical consumable? Water, lithium hydroxide, oxygen, electrical power, or what? And how long will it last?
Well, as I mentioned earlier, it varies on how you use them. If you turn everything off, then electrical power is not a problem, but of course we have to use it. Oxygen we have more than a sufficient quantity, and the LEM is self-sufficient except for the lithium hydroxide. We're going to have to be using lithium hydroxide out of the CSM to maintain the CO2 level at a lower level. So from that standpoint, we have to use both the command module and the LEM. From an electrical standpoint and an oxygen standpoint, we can use the LEM alone.
Enough water?
Yes.
When the fuel cells aren't functioning?
Yes, the LEM has a large amount of water that it carries. The LEM cooling is done by water. It uses a sublimator rather than radiators, so we'll be using that water for cooling, and there is enough.
The individual life support system packs that were meant for the moonwalk, can they be used inside of the spaceship?
Yes.
Thank you. All right, one in the very back room.
Any thought given to cutting down communications to conserve electrical power? To setting a timeline of we'll talk to you with us and so at such hour?
I don't think it makes that much difference.
And I don't, at this time, I don't think we have to do that.
Right.
Initially, we wanted to get the spacecraft configuration under control so we knew where we were. And as I said, we've got to average about 25 amps or something on that order, plus or minus a few amps. And it's better to burn a few extra amps right now, figure out what you're going to do, and have all the capability of taking things out later. But you want to make sure that you've got a condition you can live with now.
I might say that if we're in a condition where we don't have the 220-foot dish, communications may be somewhat sporadic without the high-gain antenna, which we would probably not want to bring up because of power reasons in the lens.
I know it's probably a little premature, but seeing they have had a rough time, have you worked out any schedules for a sleep period for any of the astronauts?
No, I think this is a little premature for that.
Mary?
Chris, if the LEM continues to operate well, what is your, when the systems and the power and all that kind of jazz, what is your primary concern? Do you have any concern about the spacecraft, things working sufficiently in it to bring it back?
No, I think that with the ground situation that we have, that is the tracking we have from the ground and the maneuvers that we can give them from the ground, I think that we're perfectly satisfied that that situation is well under control.
Would extreme weather conditions affect your choice of landing sites, and do you have any idea what the weather will be like in the landing sites?
I haven't looked at the weather yet, but we would still have range control during re-entry, some hundreds of miles, perhaps 1,000.
What will the procedures be for the rest of the night?
They are not defined yet.
All right.
Chris, you were in a catbird seat on John Glenn in a retro pack that didn't come off, Scott Carpenter in an overshoot, Dave Scott in a stuck thruster. How would you, and forgive me if I put you on the spot, but how would you classify this situation as regards to these that we are familiar with a little bit?
I'd say this is as serious a situation as we have ever had in manned space flight.
This man in the corner is.
Jim, two questions. One, with the situation of using the lithium hydroxide in the lunar module, will there be any chance that the air might get stuffy at all before this is out? And could you paint a picture for us of what it's like in the command module with it powered down? What does Swigert, whoever's in there, see? Is it just the lights from the computer or the disk keep blinking, or what?
Well, we'll first let me answer the one about the lithium hydroxide. We'll be using the lithium hydroxide out of the LEM, and then we'll be using some out of the command module, and then some out of the LEM, and then some out of the command module, trying to keep the environments in both spacecraft acceptable. The disk key has been turned off. The command module is powered down now, so there won't be any lights in it at all. They'll be using this flashlight. We have 3 re-entry batteries in the command module, and we have no way of recharging these things now with the fuel cells gone, so we don't want to waste any of this valuable electrical power by running unnecessary equipment in the command module. Now we do have the capability of powering some things in the command module from the LEM as long as we keep this power load down low via the umbilical that runs through the tunnel.
In a report a few moments ago from the Aquarius, they were still having problems with the roll, and they had not attained the configuration that they wanted. My question is, do you know precisely where they are, and are their computers operable and in tune with yours? You've talked about perhaps some of the instruments giving you bad readings. Do you know at this moment precisely where they are?
Oh, yes, I think we know the trajectory they're on, if that is your question. Yes, sir.
We may not know exactly what their alignment is. I think that we were fairly well satisfied that the CSM and the LEM were properly aligned with each other before we shut down the CSM.
Is there a hole that was caused by this?
I don't think we know that.
As far as we know where the LEM is, but it doesn't know where it is, because when we went in there and powered it up, we only went through that part of the power-up procedure that brought the IMU on the line in a known configuration. All that equipment, all that erasable memory that has to do with where it is, isn't in there, and the LEM really doesn't navigate normally between the Earth and the Moon anyway. So we're going to have to keep track of it from the ground. But the main thing is the LEM provides the attitude with respect to the stars, and that's the reference with which we'll use for all powered maneuvers.
Well, these men are very anxious to get back to work, so we're going to take about 2 or 3 more questions and then cut it off. So
Chris, I know this is very early to answer this kind of question, but Project Apollo had a pretty carefully thought out lineup of things that you wanted to do. You curtailed it by eliminating flight number 20. Now, for practical purposes, you've eliminated flight number 13 as far as lunar exploration is concerned. Can you give us any idea at all what this breakdown is going to do to the rest of the program?
Well, I'm sure that we will reassess the landing sites that have been chosen. We'll reassess the command service module itself. We want to satisfy ourselves that we've done the best we can before we launch again. I believe that in terms of the landing sites, we will probably reconvene and go through our landing site selection again to make sure we're satisfied that that is true. I think we've done that enough now, however, that we can probably come pretty close to laying out the sites that we'd like to go to.
Would you think that the 6-month hiatus between shots that you've laid out for yourself now would be sufficient to get a handle on what was wrong with the service module and correct it? Or do you think that there might be a delay, a stretch out as a result of that?
Well, I think that's very difficult to answer, Bill. Let me say this. I don't think we would hesitate to wait a longer period of time than 6 months if we were not satisfied.
The dips burn that has been referred to, would that have to occur behind the moon out of radio contact, or could you fix it so that you could perform it in radio contact?
It could be in radio contact, possibly.
Here. On the backup systems, the way the various backup systems, as far as moving into the LEM and the various systems that have backed themselves up, the emergency systems, are you satisfied with the way they've worked? And is this giving you an insight into things that might be needed in future flights, even more backup systems that would back up some of these possibly that have now failed?
Well, the command and service module was designed to be an independent spacecraft, and we built the redundancy into the spacecraft. This was, whatever happened today was one of those cases that's very difficult to design for. We had something happen which was a major consequence down in that bay, I think, because of the multitude of things that occurred when you lose 2 fuel cells and an oxygen tank, and the oxygen runs out of the other, and all that. That's something very significant. It'd be very difficult to design against that. We were fortunate that we're on the way to the moon with the LEM on board, or LEM attached.
So I wanted to ask about, you say that on the return flight this could have been extremely critical. Are you thinking now in terms of something to do in the event this should occur on a return flight?
I think that would be pretty near impossible to do at this time with that vehicle.
One here, and then we're going to take Mary, then we're going to have to close it up.
Did the fact that you went into a hybrid trajectory
yesterday, pulling you out of free return, is that going to cause you any troubles in trying to get back around the moon?
No, as I said earlier, we're not on a free return right now, but it would only take a maneuver of about 20 to 40 feet per second to get you back on a free return. That could be done in, say, 5 or 10 hours from now, if we chose to do that.
Chris and Jim, do you have any feeling of how the crew feels, and also Marilyn and Mary on this situation?
I would only guess that the crew feels that the situation is under control, but that they were in a serious condition, and they knew they had a job to do, and I don't think they stopped to consider what their personal feelings were at the moment. You'll have to wait and see how they felt about it themselves. As far as the wives are concerned, I'm sure Deke Slayton has talked to them, but we have not.
I think when you're in a spot like that where you're busy and you have a lot of things to do, I think you just go ahead and do them. And the crew's been jumping back and forth between spacecraft and powering systems up and down and maneuvering around quite ably in the spacecraft, and they've had the situation well in hand. So I think they've been probably too busy to sit back and...
Certainly they have remained very calm and responsive to the discussions from the ground, and I'd say they have the situation well under control.
We're going to continue to schedule these briefings throughout the mission whenever there's a point where we think interpretation would help, and we'll be back again, but I think we ought to get back to mission control now.
One quick one. If you went...
That was the news conference in Houston, the first since the trouble developed with Apollo 13 at 10 o'clock Eastern Standard Time last night now, some 4 hours ago, and which has caused a cancellation of any plans to land on the moon and has developed into a critical situation for the astronauts as they must go to a backup emergency system to get around the moon and back on the way home safely. The conferees you heard there were Christopher Kraft, the Deputy Director of the Manned Spacecraft Center, an astronaut, James McDivitt, who's now the Apollo Program Manager in Houston, and Sigurd Sjoberg, the Director of Flight Operations. Christopher Kraft said that this is as serious a problem as we have ever had in space, but he said the chances are excellent for the safe recovery of the astronauts if the LEM continues to work well, the lunar landing craft, which is still attached to the command module and whose power they will need to get around the moon and back on the way home. He says, Chris Kraft, at this conference, that it is a safe situation at the moment. He has confidence in the astronauts, of course. They have plenty of oxygen in the lunar module for the entire trip that would get them back home now on Friday around noon if they land in the Pacific, a little earlier if it is decided to land them in the Atlantic, although Mission Control clearly would prefer to land in the Pacific, where the helicopter carrier ship, the Iwo Jima, is waiting and has been on station for some time for the planned return from the moon. There is no recovery ship in the Atlantic, we learned tonight, although NASA earlier had said that for launch at least, a destroyer, the USS New, was in the Atlantic in case of a launch abort. Presumably it has left its station now. An Atlantic recovery would be a little southwest of that bulge of South America, southwest, that is, of Recife, Brazil. The interesting possibility was raised at this news conference that the cause of the difficulty could have been that the spaceship was hit by a meteoroid. This has always been considered a possible danger in space, but it had been pretty well dismissed as man had ventured further out there and had finally gone to the moon 4 times successfully before this trip. But it does seem that there was an explosion. Something violent took place in the service module, that is the large tank-like section behind the command module where the fuel cells are located, and it caused a venting of oxygen. This sounds as if something broke through the skin of the service module to cause that venting, and the suggestion has been made and not been knocked down by NASA yet that it might have been a meteoroid strike. However, there are a lot of tanks under considerably high pressure in that service module that also could have exploded, causing this considerable emergency. They will apparently have communications throughout this trip there and back, despite the fact they will go in a powered-down configuration. That is, they'll use as little power as they possibly can, but they will not power up their strongest antenna, and communications may be a little bit spotty. Lovell is reporting now that he cannot see stars out of the LEM windows because the windows are covered with debris, presumably from the mishap. Now, how serious that could be, since it means that, I suppose, his problems of alignment now become a little bit more difficult, don't they, Wally? He was going to perhaps have to align the platform of the spacecraft for the firing by sighting on the stars.
Well, this is the crudest way of aligning. That's looking through the windows at known star patterns, but looking through the optical device would be the next check. And I don't understand what he's really saying there. Obviously, we can't go out and turn on the duty windshield wiper as we do in an automobile to clear the window. So I have to think this one over a bit to see what he's going to do to align.
You know, we have, for the first time on this flight, I think, fortunately, circumstances turn out, a network correspondent in Mission Control who can report to us the mood and the attitude and the feelings there at this time of rather considerable crisis. Our correspondent is Roy Neal. He's been inside Mission Control right along this evening since the crisis developed at 10 o'clock, and here he is.
Control, we have learned that a group of astronauts are at the moment working in a simulator here at the Manned Spacecraft Center, trying to duplicate the conditions of the men out in space, trying to find out in particular if the men can see stars, for if they can, some power can be saved aboard the lunar module by using stars for aligning the computer. If not, that power would have to be used, and power at the moment is the critical factor aboard the lunar module. Conservation of power is the big thing that they're talking about here. The controllers are working
Mission Control, 3,100.
Yes, now I hear Mission Control in my ear, but it's overmodulated.
Incidentally, they're finding at the moment it is time in the Atlantic, 133 hours round elapsed time. The situation is still a difficult one, a critical one still being worked on. Roy Neal in Mission Control.
Back here at our CBS News Space Center, we have with us Leo Krupp, test astronaut, engineer for North American Rockwell, who's been with us on all of these Apollo flights and many flights before that. Leo, I'm wondering, I think most of our viewers probably heard most of that news conference by now, and there were some rather technical questions raised that maybe you could help us with. If we could go back through a couple of the notes I made here. One thing they talked about was the lithium hydroxide, which seemed to be the only critical factor in providing oxygen. They have apparently do not have enough lithium hydroxide in the lunar module. They're going to have to depend on the command module for part of that. Lithium hydroxide, we know, is the purifier, the filter through which they take out the carbon dioxide in the air and recirculate it for oxygen. But how is it contained, and what does this mean, having to work back and forth to the command module, and does the electrical power affect that supply?
Well, Waller, they have the environmental control system in the command service module powered down to conserve the power. So this means that they're utilizing the lunar module environmental control system. Now, the lithium hydroxide canisters that we have in the command module take the air, the oxygen that's being used in the command module for the crew to breathe, and it circulates that through the lithium hydroxide canisters, and it filters out the impurities and the carbon dioxide. Now, the concern here is the fact that they have the command service module system powered down, whether the LEM lithium hydroxide canisters will do this job. Now, I don't think this is a problem yet, but they'll probably be keeping a very close watch on the amount of carbon dioxide that they're building up in the cabin to see if it is a problem.
So, Leo, are these, as I remember, and I'm not sure of this, are the canisters interchangeable where you can use the command module canisters in the LEM? That was the inference that McDivitt made.
Yes, I don't think it's a problem with the number of canisters, Wally. I think it's just the capacity of the LEM system. The LEM system was designed for 2 people, and we have 3 people surviving on it.
Yeah, but McDivitt also made the point, and I don't think you were up with us at the time, that there's more than enough oxygen to supply this requirement, and that they had, I believe he said
48 pounds.
48 pounds, and
they use 6
plenty of
pounds a
oxygen
day.
for depressurization. So the only constraint then would be to clear out the impurities, the carbon dioxide.
That's right. There's no shortage of oxygen.
No.
The problem is scrubbing it through the lithium hydroxide system.
Yeah, and this, of course, is done with an electrically driven compressor, which drives the used gas through the canisters, which has some back pressure, much like a little vacuum cleaner. And as a result, the back end of the vacuum cleaner gives you cleaned out gas. So you've literally removed the carbon dioxide and water and impurities.
So their concern is not with the amount of oxygen on hand, but that they've got enough battery power there to
run that
continue
fan.
to run the fan, and run the oxygen back through the air back through the lithium hydroxide containers. All right, now another question here on this matter: the passive thermal control mode. As we know, all of you out there who have followed these flights in the past, and I assume most of you have, in going out to the moon and back, because there's the temperature of, 450 minus or plus, depending on whether you're on the sunny or the shadow side of the sun. You can't stay in one position too long, or you bake on one side and freeze on the other. So they turn the spacecraft around slowly, one revolution an hour, I guess it is, isn't it? Or it's
3 degrees a second.
3 degrees a second. So that's 1 an hour, 360 and 60. 1 a minute, 60 minutes. So it's well, anyway, they need the RCS system, those little jets, to do that job.
They can use these little ones on the, well, there's, of course, our display of the rotary or rotisserie mode, as you can see on the screen, or I guess I'd like to call it the barbecue mode. It always confuses me to call it the rotisserie mode, but that way you end up heating and cooling the opposite sides of the vehicle, so you have a universal heat path through it. But you can use the same, you can use the thrusters on the LEM to start this motion, and it's really a coasting motion. We haven't done that one either, by the way, Leo, in simulation, I recall. We've used the command service module combination to set this up.
Yeah, so that's one of the problems that Jim Lovell was reporting on, is that when he was trying to use the reaction control systems of the lunar module to
fly the
vehicle, he was getting some cross-coupling because the center of mass is offset from here.
What do you mean by cross-coupling, Lou?
Well, when he would go to put in a pitch maneuver or a roll maneuver, he would couple into a yaw at the same time, because the engines are designed to operate this vehicle here with the center of mass associated with these rockets. Now, when you're trying to fire these engines to control this whole mass, your center of gravity is offset, so you don't get a pure control movement when you fire a jet.
Well, that's very interesting, because what they're talking about, they mentioned there, was jettisoning the service module, which isn't doing them any good at the moment, apparently.
Intuitively, I like that idea, but we haven't simulated this configuration. But now you've removed this large mass. It appears it's not usable. It's just along for the ride. It does 2 things for you. It gives you less total system to accelerate with this descent propulsion system, which is the engine we'll use in the back of the moon, as you heard Sig Schoberg describing it. The other thing is that these thrusters that you see in these areas that do give an attitude change don't have as much cross-coupling, as Leo said, meaning you have to drive this thruster is long to make this whole stack move. You just move, you're basically moving the LEM, and this little bit of an ice cream cone is going along with you, which is all you need to come home. But there's no reason to throw this away until that decision is made that this is no longer usable.
Well, this possibility was discussed, but as it was pointed out, we have done descent propulsion engine burns in a dock configuration. Jim McDivitt did this on Apollo 9, as a matter of fact. But there has been no flight testing done with the descent engine firing with the service module separated. So I imagine the NASA people are looking into this very closely. And as they mentioned in the press conference, they're busy right now doing some simulations, and I'm sure that these people will rapidly get on top of this problem and come up with some good configuration changes and some procedures for these people.
Leo, you didn't look too happy as Wally was describing that. Do you yourself have some doubts about it, or as a test engineer, would you not like to try it without in-flight testing first?
Well, I think we always like to have in-flight testing to verify it, but sometimes it's not feasible to do this. But I'm sure that the NASA people back at Houston are looking into this right now, and they probably will verify on their simulations and make an analytical examination of this possibility.
Let's see if I have more technical questions for you, Leo, going back through the notes that I made during the recent news conference. Well, I don't think I have. They've talked about having no problem separating. I guess that's perfectly clear what needs to be done. They have to, each of these stages has to be jettisoned before they can finally re-enter. Only that little command module finally can come back in. If anything else is attached on there, the dynamics, thermal dynamics are all wrong, and it just won't work. That literally would burn up in space. There's a heat shield built onto that command module on the flat side of it to get the men back safely, and there's no other way to do it. It has to be free.
There are some gee whiz things that could be discussed. The typical separation routine requires the thrusters on the service module, for example, to draw it away from the command module, although this just adds safety to the separation maneuver. In the same light, the LEM, when it's separated from the command service module, is literally flown away, accelerated away, so that it too is on a separate flight path. So these kind of what-if or gee-whiz statements will cause a little bit of midnight oil burning. Of course, we're burning some ourselves at Mission Control Center, but they're all within the capability of what we have here. So I'm not really worried about it, just a case of consideration is required.
Now, they're talking about right now, Jim Lovell and Fred Hayes are in the lunar module, and Jacques Swigert is in the command module. And it was suggested by McDivitt, or I think maybe Kraft, that they would probably, two of them would probably stay in the command module, asleep in the command module, with one remaining on duty in the lunar module. It will be their configuration for living for the next 4 days.
I think Chris was making a guess, and he made that point clear himself. One thing for sure I'll say, and if I were in command of the mission at this point, there would be one man awake all the time. This is what we call an emergency mode, and it's like general quarters or battle stations. You can't afford to let this run on its own anymore, as we had developed it in the last few missions, where all three crewmen slept simultaneously. In this case, one will have to be on watch. Now, where the watch station is, obviously the only thing that's working is the LEM, so the command module might be the sleep house.
Yeah.
I'm sure they won't all be sleeping at the same time.
No, I'm sure all three are going to have trouble getting to sleep at this point.
Gentlemen, we're going to pause now. 5 seconds for station identification. Let us review for you quickly now what has transpired this evening. The flight of Apollo 13, man's 5th trip to the moon and what was to have been his 3rd landing attempt, was going splendidly tonight. When just about 10 o'clock Eastern Standard Time, 4 hours and 17 minutes ago, and it seems like the longest 4 hours and 17 minutes we've had around here in some time. Must have felt the same way in Houston, up there in the command ship. But at that time, around 10 o'clock Eastern Standard Time tonight, something happened aboard the Apollo 13. It is not known yet just what happened. Perhaps it was hit by a meteoroid. Perhaps there was an explosion. At any rate, the electrical power supply for the command module, service module, and for the mission, indeed, went out. That electrical supply is furnished by 3 fuel cells, so-called. Liquid oxygen and liquid hydrogen are combined, and that chemical combination supplies electricity. Byproduct is water. This is the main supply system for the mission. There are alternate supplies of electricity through batteries. Well, this system was hit. It went out with a bang, an explosion, a venting of oxygen from the spacecraft itself. Just suddenly, the men found themselves without power, almost as if the fuse had blown. Indeed, that's just the way they reported it. The 1 and 3 fuel cells went out. The 3rd fuel cell, number 2, began draining very rapidly. They took emergency action, shut down all the electrical power they could to conserve what electricity they could, and then it was decided that clearly they could not land on the moon. And mission control and the men in the spaceship began considering instead how they could be sure to get back safely from their mission without landing on the moon. It was decided that the way to do that, and indeed it's written in the flight plan, would be to use the descent engine propulsion system, because they are still joined to the lunar module. So the descent engine of the lunar module, operating on its own battery power supply independent of the fuel cells, will be used to provide enough boost to swing the command ship and the lunar modules connected to it around the moon and back on a trajectory toward Earth. This all now means no moon landing, but would mean a safe return on Friday in the Pacific Ocean. It is believed they have enough oxygen aboard, enough water. They, of course, have the food aboard and enough power to do all of the necessary maneuvers for that successful landing in the Pacific on Friday around 12:13 p.m. Eastern Standard Time is the calculation now. If it should turn out that they begin to run short of some of those consumables that they find so essential to life, indeed, they would come back in the Atlantic, and that can be done getting them down about 9 hours earlier than otherwise. They could land in the Atlantic, although that is a contingency landing area, not a prime one. The ship waiting for them, the Iwo Jima, is out in the Pacific. There are no ships in the Atlantic, but the Coast Guard is working on getting something down there now and is surveying the available surface craft to see what can be done. The situation is certainly critical. It's been called as serious a one as we've ever had in space, but the officials at Houston say their chances are excellent of getting back safely, and the situation is safe at the moment. The next critical time will come, if all continues to go well now, no other major malfunctions, tomorrow night around 9:30 p.m. when they fire that descent propulsion system engine to put them in a proper trajectory to come back to Earth. Bruce Morton has a report now for us from the Manned Spacecraft Center in Houston. Bruce?
Walter, Leo was talking a few moments ago about the efforts here to work out alternate solutions in the simulator. We weren't so foggy outside, you could see the cars heading into mission control, astronauts, trajectory analysts, everyone coming in as soon as he heard the word.
Has a report now for us from the Manned Spacecraft Center in Houston. Bruce?
Walter, Leo Krupp was talking a few moments ago about the efforts here to work out alternate solutions in the simulators. It weren't so foggy outside, you could see the cars heading into mission control, astronauts, trajectory analysts, everyone coming in as soon as he heard the word. And in fact, the Apollo 13 backup crew, we learned, is now in the simulator, working out some of the possibilities that are being considered. Among them, of course, Ken Mattingly, the man who was to have made the trip. We've been talking here with some of the people from Pratt & Whitney who make the fuel cells. They are as baffled as everyone else by what happened. People mention explosion, people mention meteorite. The Pratt & Whitney engineers, they just don't understand what went wrong with the system. They can't find anything that points to a malfunction in the fuel cell itself, but they don't really have another explanation either. Vice President Agnew, who was to have made a visit here tomorrow, has canceled that now, presumably on the theory that this is an emergency, that everybody's working hard, and it really isn't the day for a ceremonial kind of visit. One other argument against the Atlantic landing that's being made here, floating back, or I should say through ground lapse time, if they go to the Atlantic, it comes out to about 133 hours into the flight, which is about 3 in the morning Eastern Standard Time, which means they'll be coming down in a part of the Atlantic where probably there won't be any ships waiting for them. And they have to do it at night, which makes, obviously, landing that much more difficult. They can't see where they're going well, and the aircraft, the ships they're looking for, they have a hard time spotting them. There are 2 C-130 aircraft on Ascension Island, which would be out in case of an Atlantic landing, but doing it at night would certainly make it a whole lot tougher, and obviously NASA would prefer to wait for the Pacific. I have just one note about the families. Mrs. Lovell is home with her children, all of them listening to the air-to-ground conversation, which is always, as you know, piped into the astronauts' homes. Mrs. Fred Hayes is home, too. She's had some excellent advice about what's going on from 2 astronaut guests, Neil Armstrong and Alan B. Walter?
Jack Swiggert's parents, you know, he is a bachelor, one of the 3 in the space program. Interestingly enough, Ken Mattingly, the man whose position he took in the last day before the flight because of Mattingly's exposure to German measles, well, Swiggert's parents out in Denver heard the news tonight and reported that they were very worried, that they were stunned by the news, but they, according to a NASA spokesman who rushed to their house shortly after the news came through, said they're taking it very well. They realize that there's a problem and that everything possible is being done for the crew's safety. In their efforts to use as little electrical power as possible, the crew may turn off their lunar module primary guidance system. Mission Control made the suggestion, and it quickly added that the decision shouldn't be based on whether or not Lovell and Hayes can see that, so can set that guidance system back up at a later time. If they find they cannot reset it, they'll leave it on so that the electronic brain can continue to maintain an accurate calculation of the spacecraft's position. This matter of communications may be somewhat critical, too. Fred Hayes reported just a few moments ago that the quality of communications with the ground is varying greatly from good to poor. I suppose that is because they have turned down their high-gain antenna, which takes quite a lot of power, and are using the low-gain antenna, which does not take as much, and perhaps they are, I don't know whether they're in touch with Goldstone, which has the big dish to receive them and transmit, which is quite a lot more powerful. It takes a certain amount of power, and if you put it into the ground, you don't have to put it into the spacecraft, I suppose, in a certain balance at any rate. But they may have some communications problems, and we've had the first indication of it from Fred Hayes. How critical is ground communication, Wally and Leo? I know obviously they want it for all of the information that they can get from all the engineers and computers on the ground, but is it critical? Can they do all this on their own if they had to?
They're going to need a lot of help on this one. The ground communication in this case, I think, will be required in that the onboard computer of the LEM, which McDivitt made note of, it didn't make a big note of it, is not designed for flight between Earth and the Moon. It's designed for flight around the Moon. You can only store so much data in a computer memory bank, if I can describe it that way. So it was optimized, of course, to fly around the Moon. Therefore, we'll hear more about what its capability is. The ground can inform them, for example, what precise attitude to put the vehicle in using the LEM guidance system. Really what you talk about in the navigation of these vehicles is an attitude rather than where it is. And it's a celestial attitude. When that descent engine has to be burned, it has to be in exactly the right attitude. The engine has to be burned for exactly the right amount of time to change its velocity a precise amount. So these things I think we'll find will be talked through from the ground. Now, I'm quite sure you're right about the choice of antennas. The attitude of the vehicle, in turn, affects the communication. So there are enough variables there that they can work that out.
At the Grumman Aerospace Corporation in Bethpage, Long Island, Chief Test Pilot Scott McLeod standing by, and Scott can fill us in on how the LEM systems are performing, just what they're probably doing in the LEM right now. Scott?
Well, Walter, if I could, I'd like to make a few positive comments. on probably what they are going to do or what we're prepared to do. First, the dips burn, the descent propulsion system of the...
Trust pilot Scott McLeod standing by, and Scott can fill us in on how the LEM systems are performing, just what they're probably doing in the LEM right now. Scott?
Well, Walter, if I could, I'd like to make a few positive comments on probably what they are going to do or what we're prepared to do. First, the dips burn, the descent propulsion system of the LEM. We have practiced this numerous times in the LEM simulators, and
Scott can fill us in on how the LEM systems are performing, just what they're probably doing in the LEM right now. Scott?
Well, Walter, if I could, I'd like to make a few positive comments on probably what they are going to do or what we're prepared to do. First, the dips burn, the descent propulsion system of the LEM. We have practiced this numerous times in the LEM simulators, and I'm sure, as you recall, in LEM 3, this was performed in Earth orbit by Jim McDivitt and Rusty Schweikert. So this is no new thing, really, to the LEM. We have been practicing it a number of times. In addition, I think there's some concern about the oxygen remaining. The LEM has roughly, I think, about 45 hours of oxygen, and in addition, if we don't go out on the 2 lunar walks and therefore don't dump our cabin pressure, we have, I'd say about 48 hours worth of additional oxygen. So I don't anticipate this to be a large problem either. Aligning our attitude gyros in LEM, setting the 8-ball up and aligning the IMU, again, can be done with assistance from MISFIN and by star sighting. So I think the situation really is well in hand by the crew that's up there.
Thank you, Scott. Do you have any idea what they would be doing up there right now? Well, just what they're up to?
Well, let's see. Probably at this time they have aligned their IMU.
I hope they have better communications than that.
Pardon?
Scott,
yes.
I don't know whether you can hear me. Nod your head if you can hear me.
Yes, I can.
Well, I can't hear you, which may be because your attitude is such that your antenna is out of line with us.
Possibly so.
There you are. Now you're back. We missed the answer to my question about whether you had any idea what they're doing right now. At least it didn't come through to us here in the center.
Yes, my guess would be that they have or are aligning the IMU and setting up their attitude gyro in preparation for the burn that will take place after they get around the moon.
Which is another 19 hours or so from now, I think.
Yes. What I was saying, Walter, is if you didn't hear me, I don't think that there's any great problem or great worry right now on the positive side of things.
Well, we're glad to have that from you, Scott. I think we're getting that kind of encouraging report from several sources, including the fellows down in Houston. Wally Schirra had a question or a comment to make to you. Wally?
Scott, what I had heard as a report from Jim Lovell, the windows had some debris on them, and I think you should point out over your head there the optical sighting device that's used for the alignment, that the windows are merely used to get initial attitude reference, and then the precise measurements are done through the telescope. Can you point that out for us there?
Green, this is the AOT, the alignment
Well, what he's pointing at
optical
is the telescope. And the window is just in back of his head as you see it. Where we see it.
Scott, we've lost audio from you again, but if you point to these things, Wally will point out what you're doing. So why don't you just point around these items? maybe you can lead him.
Yeah, what we're looking at there is the AOT, or the optical telescope, and it looks something like a periscope to us here, and it's not at all dissimilar. And that device couples into the onboard platform and computer so that they can, in fact, align the system much as they do in the command module. The windows in back you were what they were referring to as the items that had debris on them, and of course there's a window on either side, and Scott's reaching to the other side.
If they had debris on them, wouldn't the telescope have debris on it as well?
It's a very good question, and I'm waiting for that answer from Jim Lovell. I suspect we'll find it out that way.
Scott, I don't know whether we've got audio with you again or not.
Try it.
Now, this simulation is almost too real. This what we're hearing from Houston. They're having the same sort of problems with the actual spaceship. If you have your voice again, what's your answer to that? Do you think that the telescope would likely be interfered with if there is debris on the windows as well?
If you can read me, I'm not familiar with the debris problem. I don't know where it came from. There is an eye guard that's located on the eyepiece of the telescope, but it's, I doubt that it would take any debris off. Can you hear me?
The debris apparently is outside the spacecraft. They said it seemed to have come from the initial problem, whatever they had, the earlier venting explosion or whatever. So it's apparently outside on the windows. But at least I guess we're going to have to wait till we get that question answered from Houston and from Jim Lovell himself, who must be in touch with Houston about the matter.
It's
I do have a
unfortunate.
report that the Navy says it has no ships in the Atlantic recovery area. The Coast Guard is continuing its check of merchant marine ships to see if there's anything down there. They would have 3 days, 4 days almost to get there till Friday morning early, and that is a busy merchant marine area, certainly along the coast of South America and between South America and Europe and West Africa. So the real problem of getting a ship there of some nature with 4 days to go, I shouldn't think would be that great one.
We have a whole, I would literally say, batch of contingency areas, contingency techniques. And all over the world we have aircraft on alert that can be deployed with paramedics and parachute scuba divers who can go over the side taking survival equipment. And we've really never exercised that large net except on the case where Neil Armstrong and Dave Scott came in way out in the Pacific.
And Gemini 8.
And Gemini 8. And of course there we had a destroyer near enough and they were picked up quite soon. But we don't really need a ship there for the crew. It's the ship to pick up the vehicle. We could feasibly, if the sea state, meaning the surface of the sea isn't too rough, go in there with an amphibian aircraft and pick up the crew so that they wouldn't have to exist in this rather lousy boat. In fact, it's not a very good spacecraft at this point either, but I should add, and I'd like to amend that the command module apparently is in fine condition, so even that shouldn't be a constraint as far as recovery goes.
And they, of course, have their raft and survival equipment all there and can spend a great deal of time out on the ocean if it's not too rough.
Required, surely.
To do it. But furthermore, there are rescue aircraft in the area
yes.
already. That contingency is always available, and there are 2 aircraft based down there that can handle that area very, very nicely and are there. But that's still something to be decided later. Actually, Mission Control has indicated quite clearly at Space Center that they prefer the Pacific landing, and if all goes well, as everyone hopes it will, of course, now, if there are no further emergencies, in other words, where they will come down right where they expected to come down, just a little south of the equator in mid-Pacific.